Good morning students, 12th standard physics lesson 3 magnetism. So in this class we are going to discuss about torque on a current loop placed in magnetic field. So consider a PQRS is a rectangular loop. So the A and B are the two ends. So in the PQRS there is a current flow from P to Q, Q to R, then R to S, then S to P. So like a closed, so that rectangular loop is placed in a, that is rectangular loop, current carrying loop is placed in a uniform magnetic field. So uniform magnetic field is get from the two bar magnets or whatever it may be. So what is the force? First there is a force acts. So the direction of magnetic field in this direction. So just match it. Then the direction of current, that is middle. So like that. So the direction of magnetic field, that forefinger, the direction of current, that middle finger. Then thumb shows the direction of force on the conductor. That is a Fleming left hand rule. So there is a force acts upwards. So here force acts downwards, that's all. So the direction of current in this direction, direction of magnetic field, then thumb shows the direction of force on the conductor. Here there is a direction of force upwards, here on the downward direction. So what is the magnetic force on the arm PQ? So already we know the magnetic force F is equal to BQV sin theta. Here BQV. So here IAB sin 90 degree. So how it's IAB 90 degree? So there is a current flow, the length of the conductor, then magnetic field. So what is the angle theta? So just consider now. So this is a rectangular loop. So I am placing like that. So it's PQ or S. So there is a current flow. So there is a magnetic field in this direction. So towards from me to opposite. So direction of magnetic field. So the direction of magnetic field is parallel to the rectangular loop. So what is my theta? So theta is the angle between magnetic field and n cap. So what is my n cap? So n cap is a normal vector. So if it is now the rectangular loop is placed parallel to the magnetic field. So what is the direction of ta? That is n cap. That is perpendicular like that. So that is the angle. So between the surface, the n cap is perpendicular to the surface. So its angle 90 degree. So sin pi by 2. Now it rotates like that. So it makes an angle theta. So what is? So the direction of magnetic field from here to there, the direction of thumb. So it makes an angle theta. So that is the less than 90 degree. So it is a reduction of 90 degree. So now the angle is reduced. So it's reduced to 45 degrees. So you need to 90 minus theta. So second one on the arm QR. So what is the force on QR? That is FQR. That is sin 90 minus theta. So sin 90 minus theta equal to cos theta. Then the on RS. So now in this it rotates like that. So what is the direction of magnetic field? So always from left to right. But the n cap, that is normal vector, so it's downwards. So what is the angle? Again it's 90 degree. So its surface, so 90 degree, again sin 90, it's 1, so IAB. Then the force downwards, already I told. Then the arm SP. So again it makes an angle n cap. So there is 90 plus theta, again is cos theta. So this is a concept. So what is the angle? So theta is the angle between the magnetic field and normal vector or n cap. So just I am rotating the rectangular loop. So now first, so it is parallel to the magnetic field. So the direction of that n cap. So the red pen shows the n cap. So direction of magnetic field. Then so it's 90 degrees. So sin 90. Then again it rotates. So n cap. So it like that. Rotates means, so there is a reduction of theta. So 90 minus theta. Again it rotates like that completely. So again n cap 90 degree. Again there is a change. So like that. So it's 90 plus theta. So sin 90 minus theta, 90 plus theta, it's cos theta. So sin 90, it's 1, so IAB. So the force, magnetic force along PQ, that is in upward direction. Along RS, it's downward direction. But FQR and FSP, they are in the line of action. So the both forces in the opposite and equal, but in the same straight line. So So FQR and FSP are cancel each other because they are collinear. Then FBQ and FRS, so they are equal and opposite but not in the same straight line. Here the force in this point, here the force just it's crossed, so it constitutes a couple. So what's my couple? So for that couple we need a force and a perpendicular distance. So we have studied in the 10th standard. So torque tau is equal to force into perpendicular distance. Here two torques, here there is a force, again another force, it's a couple. So again with that section from here to there, so this section is taken discussed here. So it's force FBQ upward, FRS in downward direction. So direction of magnetic field from left to right, then n cap. So it makes an angle theta. So now what is my torque? Force into perpendicular distance. So this is a complete distance. There is a axis of rotation along AB. So that PQRS is rotated along the axis AB. So here, so what is the perpendicular distance? So this one is a perpendicular distance. So sin theta is equal to, so what's the formula of sin theta equal to opposite by hypotenuse. So what's the, this is the angle, so this is the opposite, that is x, then hypotenuse, that is b by 2, so it's half, then sin theta. So we need this from this distance, so x is equal to b by 2 sin theta, just cross multiply. So b by sin theta, it comes like that only. So x is equal to, thus from this distance, so force into perpendicular distance, so b by 2 sin theta, again that side also. So torque due to the force FBQ on the arm, so that is force into perpendicular distance. Already we have calculated the force FBQ is equal to IAB, so it's b by 2 sin theta. So similarly for RS, again same b by 2 sin theta IAB. Here A, so A is the length of the rectangular loop, B is a breadth. So length and breadth, so you need to check here IAB, here IBB, again here IAB, here IBB. So here this FQR and FSB are cancelled because they are in the straight line. Then here FBQ and FQR are added, so it constitutes a couple. So what is the total torque on the rectangular loop through the axis of rotation AB? So tau is equal to, just add it, so IAB plus IAB, here b by 2 sin theta, b by 2 sin theta, so half plus half 1, so IAB sin theta. Here area, here A into length, that is length into breadth, so L into B is area, so just replace AB by capital A, so IAB sin theta. So A cross B equal to AB sin theta, so just IAB is A, then B is B, so A cross B equal to AB sin theta. Then IA, so I is a current, so A is a area, so IA is equal to magnetic dipole moment, so it's BM. This is another form, so torque tau is equal to BM cross B. Then so tau is equal to NIAB sin theta. So there is a single turn. If it is a n number of turns, so there is a more torque will produce. So tau is equal to NIAB sin theta. Then some special cases, if theta equal to 0 or 180 degree. So 0 means, so this is a rectangular loop, so direction of magnetic field in this direction. So what is the angle? Here 90 degree. So if it is like that, so what is the direction? Here now the loop, the rectangular loop placed in the magnetic field like that. So what is the direction of torque? So now the n cap acts in this direction, so it's perpendicular to the plane, then magnetic field. So both are in the same direction, theta equal to 90 degree. If it is like that, it's 180 degree. So 0 or 180 degree, tau is equal to 0. So sin 0, sin 180 is 0, then 90 degree. So again we need to have a basic idea. Theta is the angle between magnetic field and n cap, that is normal vector. So now the rectangular loop is placed in a magnetic field that is parallel. So just that is the angle between the surface and n cap, it's 90 degree. So magnetic field in this direction, then n cap, so 90 degrees, so sin 80 equal to 1. So tau is maximum and theta equal to 90 degrees, so tau max equal to IAB. So it's the plane of the loop is parallel to the magnetic field. So this is a plane, so magnetic field from left to right, so it's parallel to the magnetic field. So in this class we have discussed, so torque on a current loop placed in the magnetic field. So you need to have some basic idea about force. So there is a current flow in this direction, magnetic field in this direction, so there should be a force in upward direction. Here the current flows from P to Q, here R to S. So the force is in upward direction, here R to S, so force is in downward direction. So two equivalent opposite force create a couple. So there is a perpendicular distance, there is an axis of rotation, so it creates a rotation. So torque on a current loop placed in a magnetic field, then two forces added, two forces cancelled. So one is due to they are collinear, here they are not in a same straight line, then it constitutes a couple, then we need to, what is the total torque on the rectangular loop PQRS. So finally you will get the torque value IAB sin theta, so IA cross B. Then if it is n number of turns, you need to use the capital N. Then they are discussing the two special cases, if theta equal to 0, tau is minimum, if theta equal to 90 degree, tau is maximum. So okay students,